Okay, students, welcome back to Unit 4. The unit lesson name is Transition and Inner Transition Elements. That is nothing but D block and F block elements. Here, S block, P block, D block, F block. So we are going to see about both these D block and F block elements. P block elements are called as transition elements because of their they are called as transition elements because of their transition in the last shell, D shell. That is why they are called as transition elements. And why F block is called as inner transition elements, because they are transited from D block elements, so they are inner transition elements. So a transition metal has a D subshell. That is why the element if it has a D subshell, then it is called a transition element. And in F block elements, the elements will have D plus F transition shell, F subshells. So it is called as inner transition elements. So in D block elements comprised of 3D series and 4S, 5D, 4D series. These are all the D block elements. These are all the subshells D block elements will have. So if we see the electronic configuration, the whole electronic configuration for the D block element, it will be electronic configuration will be 3D10 4S2, 3D10 and 4S2. So these are the inner transition elements. Basics of inner transition. Now we are going to see their properties, how they are further, their ionization enthalpy, their melting point, etc., etc. So if we consider melting point, melting point first increases along the increases as the number of d electrons available. That is, it will increase from Scandinavium to chromium, and then it will increase from Scandinavium to chromium. From chromium to manganese, it will decrease. Again from manganese to ferrous, it will increase, and again from ferrous to zinc, it will decrease. So this will be the properties of the melting point. This is how the melting point characteristics as we move along from the left to right of the transition metal series. So the variation of atomic size also depends upon atomic size also depends from left to right. From left to right, atomic size increases. From left to right. So now if we take ionization enthalpy, it will gradually increase intermediate gradually increases, filling d electrons. That is, from Scandinavium to zinc, it will increase one by one. Like that process, it will increase from Scandinavian to zinc. So this is how it gradually increases for ionization enthalpy. This gradual increase in ionization enthalpy, because reason is that due to increase in nuclear charge. Since nuclear charge increases, ionization enthalpy increases. So now we are going to see oxidation state. Oxidation state, how it characteristics, how it appears. In oxidation state, it increases. Oxidation state increases with the number of electrons. But same, this oxidation decreases. Oxidation state decreases. Number of paired electrons increase. Number of paired electrons increase. Number of paired electrons increase. So this is about oxidation state and the potential of the transition metals. So now we are going to see the magnetic properties of the d block elements. Magnetic properties depends upon the magnetic dipoles. Based upon the magnetic dipoles. It will have all paired electrons. It will have all the paired electrons. Together it is called as diamagnetism. All paired electrons are called diamagnetic. If they have unpaired electrons, it is called paramagnetic. In the last shell of it, all paired electrons mean it is diamagnetic. If all the last shell of an element is unpaired electrons, they will be paramagnetic. For example, consider this is D subshell. Neutron S, P and D. If it has paired electrons, it is called diamagnetic. If it is a single electron, it is called as paramagnetic. So this is all about paramagnetism, magnetic properties. Magnetic properties can be calculated by this formula. Where S equal to N by 2 and G equal to 2. So there are also other properties such as oxides, oxoanions of metals, etc. Formation of complexes, etc. will happen in transition elements.